Alright, so basically today we'll be deriving an expression to basically the voltage divided expression really to figure out like across two resistors in the middle, right? What's the voltage right at this point relative to ground? Okay, so basically really simple. We can say that the current going through the entire loop is just some I, right? And then just use the equation V equals IR, but in this case is going to be V naught is equal to I times our total resistance, right? So R1 plus R2. Now idea is I'm going to solve for I, so I'm going to get I is equal to V naught over R1 plus R2. Okay, now using this current we have here, this I, we're basically gonna like find the voltage dropped by this resistor. Alright, the voltage dropped by this resistor is going to be equal to the voltage here relative to ground. Right? So basically, really, the voltage at this point, I'll call that maybe V, I don't know, call it VR2, right? Voltage at this point, this is going to be equal to the current, right, times, current times R2. But current in this case is just V naught over R1 plus R2. So I get V R2 is equal to V naught over R1 plus R2 times R2. And if you can rewrite it in better terms, so I get V, we already said VR2 right here. So I'm going to say V naught times R2 over R1 plus R2. This is what you normally see on the internet and stuff like that. So really simple derivation, Ohm's law really, and little voltage drop in exercise right here, but that's about it really. So we got the expected result, quick short proof, derivation, whatever you want to call it. So yeah, follow for more like this, things like this.